Hi, I'm Andrew Armstrong and welcome to Back Office Teardown Lab. We have a kit today, another mystery kit. It's a bit of a mystery, but it's got a manual. It's pretty mauled up. Look at this. It's got this bunch of components here. You've got a transformer, resistor, diode, pretty ropey looking pin header. Look how bent that is. You've got what looks like kind of a power transformer, power transistor that's been yanked out of something because the legs definitely look like it's been recycled. It's a 2SD880. That's what it looks like to me, a 2SD880. And we have a heatsink and a book. So let's have a look at our book. And I'm really going to have to do something about this filthy mat. It's quite nice to have a manual to look at. Could help things along. All in Chinese. Yup, still all in Chinese. However, there's a quite handy guide on how you're supposed to hook it all up. It looks like a wiring thing on the back, but this is a guide of how to hook it up, so we're just going to follow that. We'll make it exactly as it is in the picture. So let's just check we've got all of our parts. So we've got our transformer. I'm going to get my tweezers here. So we've got you've got the teeny wire, which is this one. You've got the two hooked together. And then you've got the other one. Brilliant, all there. And then you've got these two output wires at the end. Oh, and the bentness is supposed to be bent. So that bent end is actually, according to the diagram, what it's supposed to be. So this is some sort of spark gap. Just like that. Should we start with the easy stuff? Yeah, why not? So we're going to solder on our sort of header spark plug doolie. Let's tin the ends. Toxic. Nice. So I'm quite enjoying these kits. I know they're like sort of mystery kits, but they're very sort of simple. So even when I have to debug them, my limited analog electronic knowledge kind of is enough. Not quite got enough solder on there. So just, I'm just looking at these parts. They definitely look like they've been salvaged out of something and then sort of made into kits. So I wonder what's happened. Sort of like someone's got a job lot of 10,000 of something, and they got to, come on Bob, figure out what you're going to do with this stuff. So should we assemble our heatsink? So there's the backing, the heatsink itself, a piece of thermal conductive plastic, and the component, and a screw, of all things. Luckily we do have a screwdriver on hand. Nice and tight. Good. So you need the diode to go onto the leg, and this is a standard diode. You'll have these knocking around. So you can actually make this yourself pretty much if you just raid your box of bits. If you can get hold of the transformer or a similar transformer, you don't need to buy the kit. There's not really anything to it. I'm going to tin these again, even though they've got the salvaged solder on it. So that diode's on there, good and proper. So we're not using a PCB here, it's kind of free form, so I'm going to try to make the best of it really. If you were doing this at home, I'd suggest you use a bit of Variboard. I could have used a bit of Variboard actually, but there you go. we'll do it exactly as it's telling us to do it. Right. So everything else just hooks up to the actual transformer directly. I'll just trim its leads. So let's see if we can figure this one out. The double wire is one of the power leads, and then the other fat wire goes to the middle pin. So we'll just try that fat wire. And because it's a transformer wire, it might well have something on it. So by something on it, I mean a varnish. Certainly smells varnishy. If you've ever done something like this before, you'll remember the smell instantly as soon as it hits your nose. I can't say it's soldering, so it's definitely got a varnish on it. So I'm just gonna gently tug on it with my tweezers. Yeah, I can see now a sort of a glint of copper on it. There we go, tiny bit going on. So this one will go onto our middle leg here. Okay, that seems to have stuck. So this other one here, that's going off to the other power lead. And then this teeny little, it's probably a feedback coil. It's going into our resistor. Let's try applying some solder, see if it'll take. Not really. Little trick, if you've got some sort of blowtorchy type thing, you can sometimes burn off the varnish. If you can get it to light and stay lit. Wasn't very convincing, I'm afraid. Let's just go back to the old scraping. Okay, just see a bit of shiny. That's all we need. So I suspect from the look of this is a kit that makes a some sort of lightning bolt that we should be able to witness between these two thingies, to use the technical term. Right, I'm just going to take some of this wire apart here. Just obviously the power connection. Oh, it's so thin. I just nomped, which is the actual technical term, straight through that, attempting to strip it. Great, we're all there. Let's just tin these up. So the negative goes to this right here. Don't be so negative. And the really tricky part is you can see those two, well, they've been twisted together. They're not even the same length. trying to get them both stripped back and tinned, it's going to be tricky. I'm going to see if there's any possibility at all to use this blow torch that seems to be having trouble staying lit. Come on. I can hear the gas, but come on, please. No, no angle, doesn't matter, doesn't want to know. So what I'm going to do is just whack this soldering iron up to the full Monty in the hope that it'd be hot enough to melt the insulation. So while that's warming up though, I'm just going to twist these together to make, again, you know, make sure they're really nicely, tightly twisted. And I do believe they are. Come on. There's a lot of gunk coming off there. Just going to keep pumping in the solder until something sticks. Right, give that a clean. There we go, we're in business. So the soldering iron, basically holding it on there, was long enough to sort of melt the varnish and turn it into a dirty bubble, and then we cleaned it off, and that allows us to actually solder a nice clean blob of solder on there. So that's our circuit, allegedly. Let's see how many, 3.7 to 7.2 volts. I've got my bench power supply next to me, set to 5 volts. So we can just hook this straight on. Let's get some fresh ends to do that with. Okay. Oh, we're ready. So that's the negatives. Just hook up positives. Right, I'm quite nervous now. I have no idea what to expect. Are you ready, boys and girls? Of course you are. You're eager to see what's going to happen now. 3, 2, 1. I briefly heard something. I'm seeing an awful lot of current, actually. So it's drawing a lot of current, but it's not necessarily doing anything with it. So it's basically acting as a dead short on my meter. So back to the drawing board. I'm quite scared now to touch any of this. I don't think there's any charge in it because there's no capacitors, but you never know. Just going to examine these connections. It all looks pretty good. So I'm just going to touch these up with the sort of iron just to make sure there's nothing wrong here. Seems okay. know if you can hear that. There's definitely something going on. It's definitely a little bit of a crackle. I can't see anything though, so we'll put something very dark under here. Let's try that again. I can see, if I look very closely, there is the tiniest arc there. But yeah, nothing to write home about. So what I suspect should be happening, and those of you at home who know how these circuits are, if you look at that there, I suspect this should be causing an oscillation really, so that should be firing this coil, you know, like so it's going zzz, but it's not, that's not happening for whatever reason. Could be that this component here is daft, or the coil itself is daft, or because it's all salvage you really don't know if it's all out of spec. But there you go. I might have a little play of it, see if I can get my 20 kilovolts, my alleged 20 kilovolts, and that might reveal the problem. This tiny little purple glow just between those two plates, very hard to see. In fact, I'll try to make it a bit darker. See it right there? That was hard to achieve, but now I've finally managed to get that working, and it took a lot of work with the oscilloscope. So if you haven't got an oscilloscope in one of these kits, you might be stuffed. But you can see it there, it's just running virtually silently, and you can see that nice little purple arc. If I try to, you know, put something into the corner there, look at that. It's vaporizing the back office card. So it's a bit of fun, and let's try with this just regular white paper. It's a lot thinner. Wowee! Don't know if you saw that, but it's eating its way through it like nobody's business. It's almost like a little laser cutter. I've removed the perfect corner. Oh no, I blew it out. So you literally, see how that, I literally did blow out the spark. It's that hard to get it instigated, the arc. There you go. It's like you literally have to get it lit again. It's kind of bizarre actually. It's very hard to tune this circuit, and I'll show you what I've had to do in the end. So let's get some light back on the subject. Right, so you can see there's a whole mess of stuff around here, a whole mess of it, and that's because I've had to spend a lot of time messing with this circuit to get it going, and it's still there buzzing away. In fact, I'm just going to knock off the power because we don't really need that at the moment. Look at all these components. You can see I've just been going nuts with these sorts of components, and I'll show you what we ended up with and sort of settled on. Because you can see it looks quite a bit different, and it's a little bit embarrassing, I have to say, because it's a bit massive, all of this stuff. And I've had to learn more about this sort of circuit than I ever wanted to. So the bit that you see the arc on is called the secondary. In fact, let's just zoom straight onto what I'm drawing. Let's pay all your attention onto what I'm drawing at the moment. Let's get through the education, the part that I didn't want to do. So let's draw a little thunderbolt, and that's called the secondary. So that's where we see the output from the transformer. And now we have two other coils actually in there. We've got this one with the little thin wires, and this is called the feedback. And then we got another one here which has got the fatter wires called the primary. So that makes up the body of the actual transformer, which is that block there. I'll describe the rest as I go along. So you've basically got a nice big transistor. So that transistor is, let's just draw it right here in the middle, and that is an NPN transistor. So it's got its base, collector and emitter. And as most circuits, that the emitter goes to ground, and I'm going to put ground as here. That's your negative, or 0 volts, however you want to describe it. So in our circuit, we actually have our primary, one of the legs of the primary is hooked up to this collector. Okay, and I'm going to show you how this works. So with a primary, it goes off to the positive. Okay, so this is your 7 volts. So just to give you an example of how transistors works, once you put sort of some voltage on here, once you get to about 0.8 volt, the transistor starts to switch. And I think if you get to about 1 volt, probably where you want to be, this will switch very hard, and it will actually just switch this to here, right? Switch this, which will be positive, through the coil to ground, and then there'll be energy stored going through this coil. Now, in order to get your spark on the other side, this actually has to stop. The circuit actually has to open, because then through I'm really grabbing at straws here, through sort of electromagnetic effects and stuff you can learn at school, it will cause this secondary to dump its power out, and then you'll get your little spark. So from what you saw that thing buzzing away and showing that nice constant arc. This has to happen very high frequency, so this could be happening at hundreds of hertz. In fact, I should have measured it on the oscilloscope. But yeah, it has to happen hundreds of times a second for you to get a constant spark at this end. So what these circuits do is use this feedback coil to trigger this transistor. Again, I don't really know the magic, but I'll tell you how I end up hooking it up. So the base of your transistor obviously has to hook to one of these feedback. So that's acting as the switch. So remember, once we get about to 1 volt here, the transistor comes on. Under 0.8 volt, the transistor goes off. So we can't. So our feedback though doesn't actually work directly if we just hook it straight to the transistor, because there's too much voltage. So what we actually have is a potential divider. So I've built a potential divider here, and I've hooked that up to the earth. And these are those big ass resistors. These are big ass wire wound ones, which are the only ones I actually happen to have. One is 100 ohms, and one is a 1K. And that's hooked to there, to the positive, and then our feedback is just tapped off the center there. So as far as I can tell by, that pretty much, I'm not sure on the mechanism for here, but it kind of works once you strike the arc. So varying these resistors will vary the amount of current that's going in on the base, which will vary how hard this is switching. So really, you want to be careful with this. I kind of think that the 1K, 1 kilo ohms here, and the 100 ohms is too much. I don't have anything else to play with though, so you might want to experiment with values far smaller than this, and I think you'll get a much higher arc, much higher voltage arc at this end. So there you go, that's what that is all doing. And the circuit that the thing came with seems to be far too crude. It's far too hard to control this. So you can see they're trying to do something similar here with this going into the base. I think it just never worked. I couldn't get it to work. I sort of played with loads of different values of resistors and things, just playing with this, trying to tune it, but it was almost impossible. So I'm guessing you've got a compromise. You've got a compromise to make, because you're obviously you're trying to basically you're trying to adjust this sine wave that's going in to your transistor, because that's what's affecting when you're getting your spark. Okay, so you want to optimize the length, because it's something that you kind of need to charge. I think there is a charging element here, so you don't want this to be too short. So if you have this very short cycle, I think you might have issues with it. Who knows? Please leave comments down below and educate me onto how wrong I am and why I'm so wrong. Please feel to click subscribe, and as ever, thanks for watching. Let's see how it fares against insulation tape. Yeah, insulation tape doesn't insulate at whatever voltage this thing is.